We will practice derivatives of other types of function beyond the polynomial function and solve differential problem for FE exam practice. Okay, that's basically the objective. So here, for example, like this is an exponential function. So what is the dA to the power of x over dx? The derivative of this guy is ax ln a. Yeah, that's simple. Yeah. Here's another one, a logarithmic function. So here, this is a logarithmic function. Like, what is the derivative of log to the base a of x? That is 1 over x, and then here ln of the base here, whatever. Yeah. So if this, for example, like this is e, so that would be 1 over x. Yeah, that would be like special case of this rule. Yeah, because ln e is 1. Yeah, that would be 1 over x. And you have also some trigonometric functions. Here are like the main ones. So I mean, this is something you should generally know or remember, like the derivative of sine x, that's like cosine x, of cosine x, that's negative sine x. Yeah. So these two are very common, and so on and so forth for like other trigonometric function. And usually, like like if you have your math book, uh, I don't know if you still have this book when you were an undergraduate student. There will be like I remember like my math textbook when I was undergraduate student. In like the cover page, there was table with like these things. So this is just an example. So here you can find like a table with all like these things and all like the rules that we covered and other things. Yeah. Okay. So basically that's all for this lesson. Uh, and let's just do like an okay, this I just did this for like the nerd student, like the mathematical nerd or the curious student. Like if some of you is curious, like why len x is equal to 1 over x. So here I just made it for you. I just solved it for you using chain rule and things like this to show you like why if you just followed like what we know about derivative and chain rule and things like that, how could you get from this guy to this guy? So I showed you like the steps here. I mean, this is optional. You don't really need to look at it. If you want to try it, like this is like solving a puzzle. Yeah. So if you like puzzle, try to solve it in your own using chain rule. If you cannot, you can look at the answer. Yeah. But this is optional. You don't need to look at this. Yeah. This is not important. And same, I did it here. Like, why is a to the power x is equal to this guy? So you can look here. This is again optional for just curious student and mathematical nerds. But for practical reason and for to prepare for FE exam, for example, you don't need to. This usually will not be in this exam. Yeah. So let's just do some example like for exponential rule. So let's like I have like my function. Let's say y is equal to e, oops, to the power x, and I'm asking you what is like the derivative of y. So if we look here at this rule, so basically the derivative of y, that would be a to the power x. Yeah, so that would be like ex and len a, len, like here. This is the rule, len, ah, len e, and len e that's equal to 1, so that would be e to the power x. So that's okay. So basically, like y e to the power x, the derivative of this guy is e to the power x. So that's my function. That's the derivative of this guy. Same. This function is the same as its derivative. Yeah. Let's do another example, like y is equal to 5 to the power x. So that's the function. The derivative of this function would be like, if we apply this rule, that would be like 5x ln 5. It should look something like this. Let's do something more interesting. I mean, this is trivial. Let me delete this. And let's do something more interesting, uh, where we can apply, like, remember here, you see this guy, 5 x to the power 2, 8x plus 1. Well, I mean, that looks somehow familiar, yeah? I mean, here I don't have x, so can I use here like the chain rule? Like, do you remember the chain rule? So I can say like u is equal to blah, 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 plus 1, and then I can say, okay, dy over dx, that is equal to dy over du times du over dx. Yeah, do you remember? Something like this. So here, this is, so basically I can rewrite this guy as like y to the power 5 like time u. Yeah. And then like dy with respect to du, like we look here at this guy, so that will be equal, like I'm solving for like, I mean, let me do it one by one, like dy with respect to du, that would be 5 to the power u ln 5. Okay. And then du with respect to dx, yeah? So I can say like du with respect to dx. So that would be equal like 2x plus 8, yeah? Something like this. Then we multiply like these two guys together, yeah? Like so, like dy over dx. That would be du over dy, like that's 5u ln 5 times x to the power something like this, yeah? So dy over dx, I can substitute the u here for this guy. So that would be like 5x to the power 8 plus 1. Okay, x to the power 8 plus 1. Then 5 times 3x plus 8. It should look something like this, yeah? So that basically will will be this guy here, yeah? So that's some problem like this. Okay, so that would be this problem here. Again, like once you get used to these things, like if you got something like this, for example, in the FE exam, so in the FE exam you can get something like this. I mean, you should, once you look at something like this, you say, oh, okay, I mean, I will just like apply this. You would know this. So basically that would be, I will apply this guy and then I will multiply by like the derivative of this guy. So to apply this guy, that would be like here, sorry, like here, and then to multiply by derivative of what's inside it, that would be here. Yeah, that's what you get here. Okay, let's look at more examples. So here, this is like a logarithmic function. So this is a rule. This is a derivative of this guy. And let's do a problem. Yeah, let's do like y is equal to log x. Yeah, log x. And what is the derivative of this function? So I mean, the derivative of this function is that we just apply the rule. So the rule is like 1 over x, and then len, what is the base is like 10, yeah, to the base 10. So that would be how you apply a rule like this. Let's do another one. This is a common one. Y is equal to len x. Yeah. So let's just apply the rule. So the derivative of this function, that would be 1 over x len, and the base here would be e. So that would be 1 over x. So always like len x, the derivative of len x is always 1 over x. That's something you should also know or remember. Yeah. It's, let's do another example like with the chain rule. Yeah, and you should become expert in this by now. So with the chain rule, let's say like y is equal to log 5, for example, like 3x. Yeah, and I'm telling you like what is derivative of this guy. So that basically you just apply the rule. Yeah, so the rule is that be 1 over x uh, 1 over or you want to do it step by step? Okay, so let's maybe since you're still not familiar with it, I'll do it one more time, like step by step. Yeah. So basically, I will say like u is equal to like 3x. Yeah, and then I will say dy over dx that is equal dy over du times dx. Yeah. So let's do this like dy over d u. Okay, so me write my new function now. So my new function would be like u y is equal to log 5 to the power u. Yeah. So like dy by du, that would be equal to 1 over u. Like here x would be u, like len 5. Yeah. That would be like this guy here. And then dy over dx, like du, sorry, over dx. So du over dx, that is equal to 3. Yeah, because like u is equal to 3x. So then we multiply like these guys together. So dy now over dx, that's like du over dx, like equal to 1 over u len 5 times 3. And like I can substitute this guy here, so that would be like 1 over 3x len 5 times 3, something like this. Yeah. Uh, so basically, yes, that's how you can solve something like this with the chain rule. Yeah. So you see like how the chain rule is useful, like as a useful like a technique for solving these types of problems is what I told you before. You can have a yeah, it's like it's a trick. You can use it for solving problem. Now let's do like trigonometric functions. So let's do like I mean you can see it here. Like I'm not gonna give you something like let's do this one. Let's do like y is equal to like 2 sine 3x. So you see here I don't have like 3x. I only have so this the derivative of this guy is like cosine, yeah, of this side, but here is not like x. This is 3x, so easy, yeah. We know how to deal with these things by now. I can say like my u is equal to like 3x. Then I will say like my y is equal to 2 sine u. And then now I find like dy with respect to du. And that would be like 2 the sine cosine, yeah, u be like 2 cosine u. Now I need to find like remember here that's the rule, like dy with respect to dx, that is equal to dy with respect to du times du with respect to dx. So now I need to find like du with respect to dx, and that would be equal to 3. Yeah. So here dy with respect to dx, that would be equal to 2 cosine u times 3. And I can substitute the u with 3x, so that would be like 6 cosine 3x, something like this, yeah. So that like the final answer will be like 6 cosine 3x. if you have like, let me show you, like if you, oops, what's going on? Let me just delete this thing. If you have like, I'll just leave the final answer here. Let me leave this one. Yeah. So, so that is like my original problem. Let me just write my original problem, like y is equal to 2 sine 3x. Yeah. If you like have some experience, like, and you know this, and you did a lot of practice, like you will just say like, why this guy that is equal to like 2 cosine 3x, and then like you take the derivative of this guy, that's 3. Yeah, so you get it like 6 cosine 3x. Yeah, you'll get the same thing here. You just have experience because you'll know, like you just treat this as an x, and then you take the derivative of this guy and you multiply it by it. Yeah. This is like a practice problem. Let's see how we are doing in time, because I don't like to keep this video long. I mean, not bad, like we are 60 minutes. Let me solve this problem. Like I usually don't solve practice problem. I let you solve this, but let's do this like as a practice. So here, find like the derivative of like cosine like square x, and I'm telling you, use like a chain rule and use like product rule, like to do this. Yeah, so let's first do it with like a chain uh, uh, rule. Yeah, so with a chain rule we can say like y is equal to cosine, oops, was like equal to cosine x square. Yeah, so I can say like my u is equal to cosine x. So basically that is like y is equal to u square, and then dy with respect to du, that would be like 2u. Yeah, and then I can also, so that's like, and then I need to find like du with respect to like dx. So du with respect to ex, the derivative of cosine is like negative sine x. Yeah. So negative sine x. It is like, sorry, not 2x, 2u here. That's negative sine x. So like if I did this, so that's like 2u, so that is like the u is equal to cosine x, so 2 cosine x. Yeah, so basically like dy with respect to dx, that would be like du, that's equal dy with respect to du, and du with respect to dx. And that's like dy with respect to du, that's like 2 cosine x, and dy du with respect to dx, that's like minus sine x. Yeah, so basically you get like it's equal to minus 2 cosine x sine x. Yeah, that's the final answer. We use this like using a chain rule. uh, let me write this final answer. So let me write the chain rule, like, so dy over dx, dy over du over du over dx, and that will give us negative 2 cosine x sine x. Yeah, that is with this one. Yeah, now let's do it with the product rule. If you remember, like, so the product rule, basically I will say like y is equal to cosine x times cosine x. So that would be my u, and that would be my v. Yeah, so dy with respect to, sorry, dy with respect to dx, if you remember, that's like u dv over dx plus v du over dx. Yeah, that's the rule. So here, I might use as like cosine x and v, like dv over dx, so that will give us like negative cosine, negative sine x, yeah, plus my v, that would be the same, yeah, so my v is like cosine x, and this is like multiplied by, yeah, uh, cosine x, and then du by dv, that would be like negative sine x. So basically, like if you added this guy, that will give you like 2 cosine x minus here 2, oops, 2 cosine x sine x, yeah. That will that would be like just exactly the same thing. So here, like you see, this is using the chain rule, and this is like using the product rule. So what I did, this is, yeah, this could be like an FE exam type of question. What I did here, okay, here's a solution, like this is what I'm showing, like this is a chain rule, this is a product rule. Here, this is like an FE, so I got this from FE example, correct? Not the same, but something similar, yeah. So FE exam practice. So I tell you which of the following is not correct derivative. So you can get something like this in the FE exam. So try to solve it on your own, and then like this would be the answer. But don't look at the answer. Just try to solve it on your own. Here is like another example. So you can pause the video and do this for practice. And remember, I will make a tutorial video where I will like show you how to solve this thing. The tutorial video is optional. You don't need to watch it. Only if you need more help, if you need more practice, you watch the tutorial video. You don't need to do any exit ticket. You can do one if you like, if you don't, or if you need to say something, but you don't have to. It's just like it's optional. It's not required. Yeah, not mandatory. So you can solve this problem, and actually which is not the correct derivative, actually is the same solution as above. But try to solve it, get to more practice. Here another FE practice. So I'm putting for you more to practice, and this is the correct answer. So basically, don't look at the correct answer. Just pause the video and try to do it on your own. Uh, one more, I added for you one more so that you can practice more and more. Uh, Again, more FE, like this is again more for you to practice. And here I put like the solution here. All this are from FE exam. Actually, you see, this is what I have. If you checked if you check this, what do you call this? If you check the slides, you'll even find more problems. I'm putting there more and more problems for you to practice in the slides. Yeah. This is your homework question. So basically, your homework is very simple, which is like true or false. Yeah, the derivative of this guy, so you can know. Like, so this is using the power rules. That would be 5x to the power 4. Here, this guy, true or false, true or false, true or false. Yeah, so that should be, that looks to me like something true, for example. And so by just inspection, you can tell, like, look at this guy, this guy, true or false. So that would be your homework problem. That's all for this week, for this review of derivatives. So if some of you were like rusty about this topic because maybe you took it like 5 or 6 or 7 years ago, that's like a refresher. If this is a new topic for you, the only way to learn this is to practice. If you want to practice more for the FE exam, I just also, like, if you want to practice more for the FE exam, I added for you some exercises that you can do. Okay, that's all for this week. And don't forget to do your homework. And yeah, see you next week.